Hello everyone and welcome to this new DIY Engineers video. In this video I'll be covering GRBL, pronounced GRBL, to be used along with your Arduino and Arduino CNC Shield module. That way you'll be able to develop a machine like the one shown here in the video. In the video I'll be covering everything in great detail, including the CNC Shield module pins, how to go ahead and connect it to your Arduino for your project, and then even great examples on how to program G-code to be used with GRBL. So let's go ahead and get started. GRBL, or GRBL, is a free open source software that's used for motion control with Arduino boards that use the ATmega 328. This enables us to use an Arduino Uno to operate a CNC machine, such as a laser cutter, 3D printer, etc. Basically, we can use GRBL and an Arduino Uno to operate any CNC machine with 3 axes, such as the ones I just mentioned. Specifically, you can make a custom CNC machine built from scratch to do this. Now let's talk about the Arduino CNC Shield. The Arduino CNC Shield basically allows you to easily connect up to 4 stepper motor drivers and 4 stepper motors to your Arduino project while connecting them to very specific pins in the Arduino Uno. Then, the GRBL software, which basically you use with your Arduino Uno, knows which pins each motor is connected to. So that way you can use the GRBL software to control your stepper motors in a very seamless way. Now, what if you don't want to use GRBL? Technically, you could use the Arduino CNC Shield without having to use GRBL. Say you simply want to go ahead and have a project with a few stepper motors and you don't necessarily want to use it for a CNC application, then you still use this device and you could control X, Y, Z axis, A axis, which are not necessarily have to be axis, by using this and referencing the correct pins on your Arduino Uno. Now, as you can see, the Arduino CNC Shield has very specific locations for each axis on your CNC machine. There's also an A axis, which can be used to duplicate either the X, Y, or Z axis by using the appropriate pins, which we'll go over, or you could operate a 4th independent axis if you're not using GRBL, by using pins D12 and D13. Now, let's go ahead and talk about the Arduino CNC Shield pins. If you look at this image, you will see that each of the axes, so X, Y, Z, and A, have their own spot to connect their stepper motor driver, such as the A4988, and stepper motor wires. On each of these spots, you also see pins to define the stepper motor microstepping settings, as shown here. You can also see the ground pins on the right. For details on the A49 stepper motor driver microstepping settings, please see my earlier video. Now on the left side, so over here, you can also see the pins to control the steps and directions of the X, Y, and Z axis. These are connected to the Arduino pins that are there if needed. But you shouldn't need to use this if you're using the Shield and Arduino via GRBL, as the pins will, as the outputs will come from the pins within the Arduino. Near the middle left, you also see pins that can be used to enable the A axis to mirror the X, Y, or Z, which are these. Note that when using GRBL, you can only use the A axis as mirror and cannot independently control a 4th axis. Without GRBL, you could simply use all axes through the Arduino pins, as the ones shown here, with a custom Arduino code. On the right, we have the pins for limit switches, which allow for both positive and negative end of the switches. And you also have pins to externally control the spindle, which you have the enable and the direction. Note that if you're running GRBL 0.9, the pin for the spindle PWM control is D11, and D12 is the Z limit, so these are flipped on GRBL 0.9, whereas this board, the one I'm showing here, is intended to be used for 1.1. There are other pins such as D12 and D13 for external control of direction and step of the A axis. You also have these other pins for enabling the coolant, abort, hold, resume, e-stop, as well as reset, another ground pin, serial and I2C communication, and a 5V and 3.3V out pins. Now, as I said before, there are 2 basic ways to use the Arduino CNC Shield. Either you're running GRBL, or you're using an Arduino with regular Arduino code on it and referencing the pins that I'm showing here. If you're running a regular Arduino code, you're simply using the Arduino Shield to benefit from the fact that it's very condensed and you don't have a bunch of wires going all over the place. You could even control up to the 4 stepper motors, all within this board. without having to mirror, meaning independently controlled. If you're running GRBL, basically you have to send commands externally from another device to the Arduino Uno, which tell the Arduino Uno what to do. So the Arduino Uno is running GRBL and is waiting for the commands. The simplest and most common way of doing this is connecting a USB cable to the Arduino Uno and sending the commands from a computer running the software, such as Universal Gcode Sender. Now let's go ahead and talk about how to install GRBL on Arduino. To do that, go to the link in the description to the GitHub link to download the code. Next, here where it says code, go ahead and click it and download as a zip. Right click and extract. After extracting the zip file, go to Arduino IDE and we'll go to Sketch, Include Library, Add Zip. So then once you're in the folder where you extracted the file, go to the GRBL master and click the one that says GRBL and click Open. I'm not going to do it because I have already imported it. Now, the next step is to go ahead and install GRBL into your Arduino, which you would do by connecting with a USB cable to your computer and going ahead and adding the code to the Arduino like you would for any other program. However, if you're going to be running a machine that only has 2 axes, so call it the X and Y with no Z axis, you would want to do an extra step. So to do that, let me first talk to you about my machine. So this is my custom-made CNC machine, and as you can see, I have an X-axis and a Y-axis. My origin is at 0, and the machine actually moves into the negative and Y-axis, negative Y and negative X-axis. And I have that motor there that is for dispensing or extrusion. It's actually not a Z-axis. So if you have a setup like this, where the spindle enable is going to activate, a motor, and then you have X and Y, but you don't have a Z-axis, then you have to make an extra change into the code that goes into your Arduino before you deploy GRBL. Specifically for the homing sequence, because otherwise when you start home, it's gonna want to home a Z-axis which doesn't exist, and since it's not gonna receive the signal on the Z-axis limit switch, it's just gonna time out and you're gonna have an error. So let me show you how to do that now. So again, this change you only need to make if you're only operating 2 axes. So if that's you, go ahead into the GRBL master folder, then click on GRBL, and then open this config as a text file. So what you'll want to do is find the following section, these 2 rows. You can see that once you start the homing cycle, you're gonna start with the Z-axis. So this is the default for a traditional 3-axis CNC machine, where the Z-axis is the first to clear, followed by X and Y. So what you want to do is edit this, change the Z, Y, and X. That way, to stay consistent, you can change this to an X and say, first move X-axis to clear, then delete this thing in parentheses in this other character, delete the extra parentheses, then optional, then move Y. So what this change would do is you're gonna home the X, then home Y, instead of having to home also the Z axis, which doesn't exist in my example for my machine. So I would then just save this, close, and then I would proceed to install GRBL into my Arduino. So I would do that by going File, Examples. In this case, I didn't show an example, but the one on my computer, I went ahead and when I made the changes, I called it GRBL XY only. That way I know, for future projects, that if I want a 3rd axis, I have to go ahead and get the original file and not the one with my change. Anyways, after that, I go ahead and click on GRBL Upload, and that opens this. You might note that it doesn't have much, but you saw all the files in the folder, so that's really what matters. Do not edit this code. All you would have to do is connect to your Arduino and click Upload. Now, before I proceed, I want to talk to you about the electrical setup and connections of my system so that you have a complete picture as we proceed to show you some examples and the use of the Universal Gcode Sender. So From an electrical standpoint, my setup is the one shown in this image. I drive the x-axis and the y-axis stepper motors through the Arduino running the GRBL. Such Arduino also receives signals from the limit switches for the x and y axis, as shown there. The spindle enable and spindle direction signals are sent from the Arduino running GRBL to the Arduino running a custom code, which will then run a dispenser motor that I talked to you about before. The Arduino running the custom code then takes a signal to the dispenser motor. Note that I actually installed GRBL 0.9, so my wiring is consistent with this. As you can see, the PWM signal from the spindle control coming out of D11. So here's spindle enable on the other one, and I'm taking out of the one that normally would have been for the Z plus limit switch had I been using GRBL 1.1. So if you're using GRBL 1.1, you can adjust accordingly if you actually want to follow this example. So now that you have GRBL installed in your Arduino, and you understand your electrical connections and you have it fully set up mechanically, you need a software to send the G code to your Arduino running GRBL. So as I mentioned before, I use UGS, Universal Gcode Sender. That's one option you can go with. That's what I'll be covering in this video. So to install it, go to the link in the description and go to this following page. Once you get there, you click on download. And you go ahead and download. I'm running this one. Might take a while to download. Once the file is downloaded, extract the contents and go to this folder, then go to bin. And then to open the program, just go ahead and double click this one. So here we are, and UGS has opened. So it looks like this. And first thing we're gonna do is go to machine. We're gonna go to the setup wizard. So make sure you click on GRBL for firmware, port rate 115200, and port, just make sure it's the one active for your connection. At this point, your Arduino running GRBL should be connected to your computer. So click connect, and it should say connected. As you can see, mine connected to GRBL running 0.9. So then I go to next. If you had any import settings, you would go ahead and import them from a machine that maybe wasn't custom made by yourself, but from someone else, and it has all those settings. If not, you have to go ahead and proceed with the setup yourself. So then click on next. So then we're going to go ahead and we're going to make sure that the wiring is consistent with the plus and minus directions, so that when you click on plus, the machine moves the way you want it to. So I'll now press -X a bunch of times so you see what happens. If you need to, just go ahead and click on reverse direction for any of the axes as needed, so that the CNC moves in the direction you want it to when you click on negative or positive for either axis. So now let's go ahead and click next. And the idea would be to press the minus or plus button to make the motor move, the stepper motor, measure the actual movement, and calculate a calibration parameter. So before I do that, let me go ahead and measure the starting point. I see about 10.5. So now I'm going to move. Now let me go ahead and measure the total displacement. And I see an actual movement of 10 millimeters, and that's the number I get. So I'll go ahead and plug this number in and update. Then I would do the same thing here. I would do it after testing, but I know the setup for mine is the same. You should go ahead and test them and get a number. And I'm going to skip the Z-axis because, well, I don't have a Z-axis. Then I would click next. Next step, we enable the limit switches. My machine has limit switches for the X and Y axis, and I would enable them and enable homing. So for homing, basically, it's going to take it as I shown you. If you had a 3-axis, it's going to home Z and then XY at the same time. For mine, it's going to do X and then Y. So this is how the homing sequence works. So I have an X and Y axis on this machine, and I have an X axis limit switch, which is this one shown here. And I also have a Y axis limit switch, which is this one shown here. So when I press the homing button, this will move that way first until it engages that limit switch right here. And then we'll go ahead and we'll move to the back until it engages this limit switch. So let's go ahead and do it. So now we go ahead and click try homing. It starts the homing sequence. We see that it touched that button. Then it's done. Then it's moving back until it engages that limit switch. Now we're officially homed. So then we click on next, and you can enable soft limits, which will prevent the machine to move beyond the safe work area or not. I have it disabled, but you can turn it on if you want to. And then you click finish, and then you're done setting it up. Now, there are other settings that you could also edit for your CNC machine. You might notice that once your machine starts, it outputs this. Step pulse, step delay, etc. There's one specifically, which are the $ followed by 100, 101, and 102, which are the X step, Y step, and Z step. These are the steps per millimeter, and you might notice that it has the numbers that we entered, which kind of show you that you could have just entered these manually into here and change them, but obviously the setup process makes it easier. You could also edit your max rate, meaning your speed in millimeters per minute for both X and Y and Z, as well as the acceleration. And your max travel, which this is just basically your machine size. You also have the $27, which is the homing pull-off. So in my machine, when I originally ran the homing sequence, the limit switch would remain engaged. So what this does is basically after it clicks the switch, it pulls back 4.5 millimeters, so this one $27, and it then re-engages by approaching slowly the limit switch and then pulling back again to 4.5. So my machine, when I home it, it's always already at an x-axis equals to 4.5 and y equals to 4.5. You could change this number by just doing $27 equal 3, and then if I reset everything, you can see that now that's equal to that value of 3. I'm going to change it since I like my machine at 4.5. If I do a soft reset and I check it, it has the 4.5. So you can do that with all the other settings that I just mentioned. So now, how do I get our GRBL CNC machine to move? For this one, we'll go ahead and start with a simple example. So here on my screen, I'm within Universal Gcode Sender. I have a existing text file with the G code that I already wrote, and here we can see the visualization. Let's zoom in into this. Now, let me first provide some context as to what's going on. This is what's showing the code. So first we do G21, which basically setting the units of what we're putting in here in millimeters. Then I run G90, which is setting the mode to absolute programming. What this means is that when I enter coordinates in this lines here that which I'll explain soon, I'm putting the absolute coordinate. The other option will be relative, meaning when I go from this point to this point and I then reference the next one, I would say, hey, go this much down versus saying, hey, go to this point. Right now we're saying absolute, so we're going to specify the coordinates of this point, this point, this point, this point, and this point back, rather than saying this point and then go so much down and so much to the left and so much up and so much right. It's all going to be in absolute coordinates by setting G90. Then we do G17, which is basically defining the current plane. 17 is for the XY. If you wanted to define the plane as the ZX, you would say G18, and if you wanted YZ, you would say G19. So we do G17. Now, next we say G0. G0 is the command used for rapid movements. So we're going to go in a rapid movement from the origin down to x equals -50 and y equals -50. Now, if you remember from my earlier image, my origin is at 0, and then my machine expands into the negative x and y. So that's why I'm putting negative x and y coordinates. So adjust this as necessary depending on how you have set up your machine. So once I get to negative 50x, negative 50y, I'm going to go and define the speed of all subsequent G1 movements, which are movements at a specified speed, at 400. And this 400, it's 400 millimeters per minute. Again, since we said the units in G21 is millimeters, this is millimeters per minute. Had we set it out for inches, it would have been inches per minute. So we're gonna go from point 1 to this other movement over here. And you can see we're at negative 50, we're still at negative 50, then we'll be from negative 50y to negative 100y. So we're going 50 down. Then from there we'll go to negative 100, then up, negative 100, negative 50, then movement number 5, negative 50 to negative 50. So where we started, these coordinates are the same as these. So then we do the last movement, which is another rapid movement to 0, 0. And then we put M2 for the program to end. So let's now go and test this on Universal Gcode Sender. Now also for awareness, if you want to show up your own code, I went ahead and wrote this on a text file, and then I just went ahead, click here, open, found the text file. It shows up here, and I dragged it and docked it on the right. So now I'm going to go ahead and click send on this. And that's it for this first test. Now, let me go over a few of the commands that you can use in Gcode for your CNC machine. We have the G commands, starting with G0, which we just used, which is a rapid movement. We have G1, which is a linear movement, basically a straight line movement, that is the same as G0, except that you have to define the speed at which you want to do it. For both G1 and G0, you define the X and Y, and if you're running a Z-axis, also the Z coordinate. You define the speed for G1, and G0 is a non-working movement, so you cannot, set a speed for a spindle or any for a laser cutter or anything like that. Whereas for G1, you could make, do work while you're doing the movements. You also have G2, which is a circular clockwise movement. Same as G1 and G0, you define the X and Y and Z coordinates. The main difference is for G2, you define some parameters that will allow you to perform a curved motion. So you can see here in the image that once we complete movement number 2 and we proceed to movement number 3, that's the curved movement. And this code is very similar to the one we just ran, with the exception of that curve. What we're going to do is define I, negative 25, and J, 25. This is the offset relative to the point that you are before you start your curved movement. So if we're in this corner and we're about to curve out, we want to know where that center of rotation is. So negative 25 is the offset on the x-axis, so negative 25 this way, and J25 being positive is up this way. That defines the radius. So we're going to rotate from this point, and we're going to get to this point by rotating along a circle with center over here. So that's why you have to define an I and J parameter. We also have G3 for the same as G2, except it's counterclockwise. Then we have G17, 18, and 19, which we talked earlier for defining the plane in which you're working on. We have G20 and 21. G20 to set the length units as inches, or 21 to set it as millimeters, which also will impact the feed rate or the speed of the movements, whether they are in millimeters per minute or inches per minute. And then you also have G90 or 91 to define the positioning style. G90 is for absolute and G91 is for relative, and we talked about that earlier. So with G90, we're saying take me to this coordinate, then take me to this coordinate, then take me to this coordinate. Whereas with G91, you would put the relative coordinates of the point you want to go to relative to where you are. So then we have M commands. We have M0 for unconditional stop, so stop executing the G code. M2 for ending the program, which we used earlier. M3 for turning on the spindle. So running M3 activates the spindle, and that will be basically a PWM output from this pins over here, unless you're running GRBL 0.9, which you're gonna get it from here. And that will be a PWM signal from 0 to 5 volts, where you define the output of that voltage by setting a speed from 0 to 1000, where 0 is 0%, 1000 is 100%, and 1000 would represent the 5 volts. So M3S0 will be 0 volts, M3S500 will be 2.5 volts, and M3S1000 will be 5 volts. So another important output that comes out of this will be the D13 pin, which is the direction. When running M3, this is a clockwise output, so you're going to get a low output on D13, so 0 volts. Whereas if you use M4, which is in the other direction, you get the same voltage if you put the same speed, but then D13 will be high. So I wouldn't worry too much about clockwise and counterclockwise, depending on what is it that you're actually doing. With your machine, just think about what do you want to use D13 for, because you're going to get low or high depending whether or not you use M3 or M4. You also have M5 for stopping the spindle. And then there are other commands such as $H for homing the CNC machine and $X for unlocking it after a CNC unlock and after a soft reset. Now, one more thing. Just because we tested a full code via running a file doesn't mean that's the only other way. Another way you can do it is just pressing G0, for example, if I want to do a rapid movement, and typing it here in the command window or in the command line. Then I go ahead and press negative X50, Y, negative 50, and then press enter. And that takes the machine to that point, and it executed them. And I say this just so you know that there are other ways of executing G-code commands. And you don't have to do a whole code. You can do just one line or two lines, especially if you want to troubleshoot or test something real quick. So now I'm here, I'm showing the code with the example I showed earlier when I was discussing G2. You see I put the I -25 and J25, and that edits this curve right here. So let me go ahead and run it. You can see we're going along the curved path. And that completes this test. Now, as I mentioned before, if you want to go ahead and take a look at this code easily and copy and paste it, you can go to my website at DIYengineers.com. I have the link in the description and you can check out the code. One more thing. Earlier today, I talked about the different commands that you can send within the command line in UGS for your CNC machine. One of them were the M commands, specifically M3, M4, and M5. Now, here we have a multimeter that's going to read the output of the PWM spindle pin on the CNC Shield, and we're going to see what happens when I send an M3 command followed by S500. That gives us an output close to 2.5 volts. If I do M3, S1000, that's close to 5 volts. If I do M5, it turns off. If I do M4, S500, again we get close to 2.5, and if I do M4, S1000, again almost 5 volts, and if I do M5, 0 volts. So now I'm going to go ahead and take the measurements off of the direction pin so that you can see the output differences when I do M3 or an M4. So now we are on the other pin, the direction pin, and we're measuring close to 5 volts. That's because the last command we ran was M4. So if I do M3, S100, we get 0 volts. If I do M4, S1000, we get 5 volts. If I do M4, S0, we still get the 5 volts. If I do M4, S500, again, still 5 volts. M3, S500, 0. If I do M5, 0. If I do M4, S1000, it's 5 volts. And if I do M5, it stays in the 5 volts because the last I sent was the M4, and M5 turns off the spindle, which would mean that the voltage on the PWM spindle output is 0 volts, but the direction is still set to the last, which was M4. This concludes this video. I really hope you liked it. If you did, please give us a thumbs up and subscribe. Thank you very much, and see you in the next one. Bye.